There are rogue planets that wander through space, orbiting no star. Rogue planets are planets, or planet-sized bodies that orbit through the galaxy as a whole, rather than circling any individual star. Whether they originate by escaping from the gravity of their parent star, or by forming without being bound to any star at all, these interstellar wanderers have crossed vast distances which we may or may not ever see. They travel through galactic space, perhaps eventually entering the orbit of another star or even slamming into another planet. These orphan worlds truly live up to the original Greek word planes wanderers. There is sound in space, but only sometimes. It is commonly stated that there is no sound in space. This is because sound waves require some medium, some kind of matter to travel through, whether air, or anything else. If two people were together in a vacuum, they would be unable to hear each other speak. However, there is one situation in which sound waves can travel through space: an explosion, specifically a nova or supernova. In such a case, sound waves can actually travel through the material forced away by the explosion. It doesn't matter that empty space can't carry sound, since the wave is being carried by an expanding wave of stellar shrapnel. If you could survive a supernova, in the moment the blast hit, you would hear the sound of a star being torn apart. There are atoms the size of mountains. When a massive enough star reaches the end of its life and goes supernova, its outer layers are blown away and only its core remains. Without the immense pressure of the complete, massive star, the star's core no longer forces hydrogen atoms, or any others, to undergo fusion, and the star no longer produces any energy. Stars are generally balanced between an immense gravitational force pulling them inward, and the constant process of fusion pushing out. When fusion stops, the star's gravity suddenly has nothing to keep it in balance and the star collapses, from a size potentially far larger than our Sun, to about 12.5 miles 20 kilometers across. This titanic amount of pressure forces protons and electrons to combine into neutrons, fusing the star's atoms together and essentially leaving it as a single atomic nucleus, a neutron star. It is not currently known what is inside a neutron star. It may simply be tightly packed neutrons, it may be some kind of neutron superfluid, or even an entirely unknown state of matter. Space is not empty. Our atmosphere is slowly, but constantly, leaking off into space. This happens on every planet with an atmosphere, as gases are knocked off by solar radiation, pulled away by gravitational forces, or even blown into space by collisions. As a result, outer space is effectively a very thin gas. It is not nearly enough to support most earthly life, or even to carry sound, but outer space is essentially the outermost layer of the atmosphere. Additionally, it is theorized that a large fraction of the mass of the universe is composed of dark matter, a kind of matter that we have not yet been able to observe directly, but whose effects we can see. Its gravitational effects can be observed in the motion of stars and other bodies, and in its lensing effect on light, see above picture. And, of course, the observable universe contains countless stars and galaxies, and at least for now, we have no way of knowing how far the universe goes, or if it is in fact infinite. If that is the case, then there are literally infinite galaxies, infinite suns, infinite worlds. But that's not all that there is in space. Our galaxy is part of a massive intergalactic structure. This is our galactic supercluster, Laniakea. The red dot shows where our galaxy is. This supercluster contains about 100,000 galaxies and stretches 520 million light-years. The Great Attractor, a supermassive object tens of thousands of times as massive as our galaxy, perhaps a supermassive black hole, is located at the center of the supercluster. Our galaxy, and all other galaxies within millions of light-years of us, orbit around this single object. And yet our supercluster is just one of many. The Earth orbits the Sun, as part of the Solar System. Our Sun orbits the galactic center, as part of the Milky Way. The Milky Way, our galaxy, orbits the Great Attractor as part of the Laniakea supercluster. Perhaps our galactic supercluster orbits an even more massive object, one which may be hundreds of thousands of times as massive as our galaxy, billions of light-years away. Our universe is an enormous, incredible place. There is so much that can be discovered, so much we can learn, and so much we can accomplish in our constant quest to uncover the truths of the universe. I hope that people never lose their thirst for knowledge and exploration, and never give up on humanity's constant attempt to learn what secrets our world holds. The future awaits.